In this video, we're going to look at an example of calculating a double integral by interpreting it as the volume of a solid. So we're asked to calculate the double integral over the rectangle where your x's go from 0 to 2 and your y's go from 0 to 8. And the function that we're integrating is z equals 2x plus 1. So down here we've got a graph of the rectangle that we're integrating over. And here I've got my function, the plane z equals 2x plus 1. All right, so in the second picture here, I'm making the volume, or a solid that we're going to calculate the volume of. So this slanted face here is the plane z equals 2x plus 1. Here is the face of the solid that would be in the plane x equal to 0. This one on the side that's kind of purplish here, that's behind the slanted one, that would be the one that's in the plane x equal to 2. This one here is in the plane y equal to 8. So what we notice here is that we've got a prism that has trapezoidal faces on the ends. So we can calculate the volume of this prism by taking the area of the trapezoid times its height. All the things laying on its side, so the height is this going along the y-axis here. All right, so what do we have? We need to calculate the area of the trapezoid. I need to know the height of the trapezoid, which will be this distance here, and that's 2, because we're going from 0 to 2 for the x's. We need both bases here. So if we plug in 0 for x, we get out 1. We put in 2 for x, we get out 5. The sum of those two is 6. So when we calculate the area of the trapezoidal face, we get 6. The height of the solid, again, it's going along the y-axis. The height is 8. So interpreting this as a volume, we can calculate the volume of the prism as area of the base times the height and get 48.